Welcome, everyone, to today's discussion on the intriguing concepts of surface tension and surface energy, their correlation, underlying mechanisms, effects of temperature and pressure, cohesion, adhesion, capillary action, critical temperature, excess pressure in droplets, various effects of surface tension, surfactants and detergents, as well as their diverse applications. Part 1: Surface tension and surface energy. It's the result of an imbalance in forces between molecules at the surface and those in the bulk of the liquid. In simpler terms, molecules on the surface of a liquid experience a stronger inward pull from surrounding molecules compared to the molecules in the interior. At the molecular level, liquids are composed of molecules that attract each other. This attraction is due to intermolecular forces, such as van der Waals forces and hydrogen bonding. Molecules within the liquid experience forces pulling them in all directions, leading to a net force of zero. However, molecules at the surface experience a net inward force, as they have fewer neighboring molecules to pull them equally in all directions. As a result of this imbalance in forces, a liquid forms a skin or surface layer. This layer behaves like a stretched elastic membrane. This is why small insects like water striders can seemingly walk on water. Their legs don't easily break through the surface tension created by the liquid's surface layer. Surface tension works to minimize the surface area of a liquid. This is because a smaller surface area means fewer molecules at the surface experiencing the net inward force. A spherical shape is the most efficient in terms of minimizing surface area while enclosing a given volume. This is why liquid droplets tend to form spherical shapes. Measurement of surface tension. Surface tension is typically measured in units of force per unit length, nm or dyne/cm. Techniques like the capillary rise method, Wilhelmy plate method, and drop weight method are used to measure surface tension. Surface energy, it is also known as interfacial energy, is the energy required to increase the surface area of a material. It's a measure of the strength of the forces between molecules in the bulk of a substance compared to those at its surface. This results in a higher potential energy for surface molecules compared to those in the interior. Nature tends to minimize energy, so when a material's surface area is increased, more molecules are exposed to this higher energy state. The extent of wetting is influenced by the contact angle formed between the liquid droplet and the solid surface. A lower contact angle indicates better wetting, while a higher contact angle indicates poor wetting. As for example, in mercury contact angle is 180 degree, so when a capillary is dipped in mercury, mercury does not rise in it. On the contrary, the upper level of mercury in the capillary is lower than the surface of the free liquid. Surface tension can be mathematically represented as the force per unit length acting along the perimeter of an imaginary line on the liquid's surface. Its unit in the international system is Nm, newtons per meter. Surface energy is measured in the same unit as energy, joules, J. Part 3: Factors influencing surface tension. With an increase in temperature, the kinetic energy of molecules rises, weakening the intermolecular forces. Consequently, surface tension decreases. For instance, think about how a hot cup of tea cools down faster when you blow on it. The increased airflow reduces the surface tension, promoting faster cooling. However, increased pressure compresses molecules closer together, enhancing cohesive forces and elevating surface tension. A classic example here is the deformation of a soap bubble when gently pressed. The increased pressure causes the surface tension to make the bubble recoil. Impurities. Surface tension can be affected by impurities in the liquid. For example, adding soap to water reduces surface tension, which is why soap is used for cleaning. Type of molecules. Different types of molecules interact differently, influencing surface tension. Substances with stronger intermolecular forces generally have higher surface tension. Part 4: Cohesion and adhesion. Cohesion is the attraction between molecules of the same substance, causing them to stick together. Adhesion, conversely, refers to the attraction between molecules of different substances. These properties play a crucial role in capillary action, which is the ability of a liquid to flow in narrow spaces against gravity. Think about a glass capillary immersed in water. The adhesive forces between water and glass pull the liquid up the tube against gravity, showing the effects of cohesion and adhesion in action. If cohesion is greater than adhesion, the liquid does not wet the wall. This is what happens in the case of mercury. Thus, when a drop of mercury or of water is put on a clean surface, the mercury drop becomes a truncated sphere since cohesion is greater than adhesion, while the water drop spreads on the glass surface since adhesion is greater than cohesion. Part 5. Capillary action mechanism. Capillary action occurs due to the combination of cohesion and adhesion. In a narrow tube, adhesive forces attract the liquid to the solid surface, while cohesive forces pull more liquid along. This results in the liquid either rising or falling within the tube, depending on the balance between these forces. A prime example of capillary action is how water rises through the roots and stems of plants against the force of gravity. Capillary rise phenomenon is partially responsible for the rise of water in plants and soils. Rise of oil in the wick of a lamp is also due to capillary action. Part 6. Surface tension at critical temperature. At the critical temperature, a liquid's vapor pressure equals the external pressure, causing the distinction between liquid and vapor phases to disappear. Consequently, surface tension also approaches zero at the critical temperature. Part 7. Excess pressure in a drop. One of the most interesting consequences of surface tension is the fact that the vapor pressure of a liquid is greater when it is in the form of small droplets than when it has a plane surface, as evident from the Kelvin equation. A liquid drop experiences excess pressure due to surface tension. This excess pressure enables small liquid drops to maintain spherical shapes, as it balances the pressure difference between the inside and outside of the drop. An everyday example is raindrops. Their spherical shape is maintained by the excess pressure caused by surface tension. Part 8. Various effects and applications of surface tension. Formation of raindrops. Surface tension helps raindrops maintain their spherical shape, as the surface tension minimizes the surface area of the droplet. This effect allows raindrops to fall through the atmosphere without breaking apart. Inkjet printing. Surface tension plays a vital role in inkjet printing. Tiny droplets of ink are expelled from the printer's nozzle due to the controlled variation of surface tension. These droplets form the text and images on paper. Water striders. Insects like water striders are able to walk on water due to surface tension. Their legs do not break through the water's surface because of the cohesive forces that create a strong surface film. Soap bubbles. Surface tension is responsible for the formation of soap bubbles. The spherical shape of bubbles is a result of the surface tension minimizing the surface area of the bubble. The colors seen on soap bubbles are due to interference effects as light reflects and refracts through the thin film of soap and water. Oil spill remediation. The use of dispersants in oil spill remediation relies on reducing surface tension. Dispersants break down oil into smaller droplets, allowing them to disperse throughout the water column more effectively. Dew formation. During the night, the lower temperature causes moisture in the air to condense into tiny water droplets on surfaces. This condensation is due to surface tension forces pulling the liquid into spherical droplets. Tears. Tears are formed due to the surface tension between the eye's liquid layer and the air. Surface tension helps to keep the tear film intact and spread evenly across the eye. Water filtration. Surface tension plays a role in water filtration processes. When water is poured through a fine mesh or filter paper, surface tension helps retain particles on the surface, allowing cleaner water to pass through. Blood circulation. Capillary action, a result of surface tension, is crucial in the circulatory system. Blood is drawn into the capillaries of tissues, allowing for efficient exchange of oxygen, nutrients, and waste products. Floating needles. Gently placing a needle on the surface of water demonstrates surface tension. The cohesive forces keep the needle from sinking as long as the surface isn't broken. Water droplets on leaves. The way water droplets form on leaves is due to a combination of adhesion between water and the leaf surface and cohesion within the water droplet itself. Soap film in bath bubbles. When you blow air into a soap solution to create bubbles, the soap film stretches due to surface tension, forming colorful and iridescent patterns. Wetting of surfaces. Surface tension affects how liquids wet surfaces. A liquid that forms droplets on a surface has high surface tension, while a liquid that spreads evenly has lower surface tension. Cooking oil in pans. Surface tension affects how cooking oil spreads across the surface of a pan. Water absorption in plants. Surface tension allows water to be drawn upward through the roots and stems of plants, enabling the transportation of nutrients and water throughout the plant's structure. Cosmetics and lotions. The texture and spreadability of cosmetic creams and lotions are influenced by surface tension. Formulators adjust the ingredients to achieve the desired consistency. Bubble bath and foams. The foamy nature of bubble baths, shaving creams, and whipped cream is a result of surface tension stabilizing the air bubbles in the liquid or cream. Insect respiration. Some insects, like water beetles, use surface tension to trap a thin layer of air on their body, which they use for respiration when submerged. Contact lenses. Surface tension contributes to the comfort of contact lenses by ensuring the tear layer adheres to the lens surface, preventing dryness and irritation. Part 9. Surfactants and detergents. Surfactants are compounds that lower surface tension between liquids or between a liquid and a solid. They have hydrophilic, water-attracting, and hydrophobic, water-repelling, parts. Detergents, a type of surfactant, help remove dirt on grease by breaking down surface tension and allowing water to penetrate.